I'll go ahead and start. Okay. Good afternoon, everyone. Thank you for coming to see our presentation, Simple Network Management Pwned, Information Data Leakage Attacks Against SNMP. My name is DERAL. I'm a principal consultant with Rapid7.
I'm Matthew KIENOW. I'm a software engineer and independent security researcher.
So why are we here? Why did we generate this presentation? So the first item we have up here is add value. Since I'm a pen tester consultant, one of the things I'm always looking to do is add value to a customer. One of the biggest problems when pen testers and consultants go on site and they encounter, let's say, SNMP with a public community string of public enabled on an internal network, what they typically do is they tell the customer, hey, this is a bad thing, you shouldn't do it. But that's about as far as it goes. They're not actually looking at the data most of the time because it's very time consuming. So toward the end of this presentation, we're going to dig into that whole time consuming thing and try to shorten that down for consultants and pen testers. But what we want to do is we wanted to go out there and we wanted to discover issues, discover ways of looking at mass amounts of data quickly, be able to look for key pieces of information that as an attacker would be able to leverage so that we can go back to the customer and teach them of the pending risk with SNMP improperly configured on their network, exposed internally and exposed externally. And of course, the last item on here is curiosity. I mean, we're all driven by curiosity. That's like most of the speakers here. We're driven to do research based on curiosity. So that's what brings us here today also. So moving from here, we show a few statistics for Shodan. Everyone should be familiar with Shodan. It's kind of online. You can get information about devices and what ports and services and stuff that they expose. Based on Shodan just recently, about a week ago, there's 7.2 million devices exposed to the internet with SNMP with a community string of public enabled. We've broken down the top four here. So we got Brazil, which is significantly high, which is kind of interesting. I'm kind of wondering where that's going. But then India, United States, and Turkey. And of course, we can't leave you guys out of it. So France. I mean, you only have 45,000, but do you really need 45,000 devices exposing SNMP to the internet with a public community string? Probably not. So the first thing we're going to do is we're going to move into an introduction to the SNMP protocol, what it's about, some basic concepts at a fairly high level. So I'm going to turn this over to Matthew, and he's going to go ahead and introduce you to the SNMP protocol.
All right, thank you, Dara. So I want to provide you with a foundational understanding of the Simple Network Management Protocol before we move into some of the information exposure vulnerabilities that we discovered in embedded devices. But all along the way, it's really important for you to remember, let's think about moving beyond using Simple Network Management Protocol for monitoring and metrics. What else is possible? So why do we need SNMP? We have a number of vendors building new devices every day. And their clients are purchasing devices from not only them, but from other vendors as well. And each of these vendors wants to provide a means of managing these devices. So if you think about managing this growing network, that's going to be difficult if you have independent management solutions. So there's clearly a need to simplify. So what does network management look like? Well, in network management, you have a manager. And this is a system that's responsible for monitoring and managing the network devices in a network. And a network device, in this case, would be running an agent. An agent is a software system that's responsible for tracking and updating the values of various logical variables, of variables related to the various logical subsystems on that device, and storing them in a local database. Now, it's able to communicate with the manager, and that communication can take a few forms. The manager can set or get the value from an agent, or it can simply set a value, or it can retrieve an asynchronous message from the agent itself. So SNMP provides these management standards so we can simplify that work, right? It's transport protocol is typically UDP, although others could be used. The agent listens on port 161, while the manager will listen for traps on port 162. Taking a quick look at the version 1 of the protocol, there are 5 major message types. These can be divided into 2 separate categories, those from the manager to the agent and those from the agent to the manager. The first 4 share a common form. Let's take a closer look at the GET request message. Now, the GET request message is used to get the value of one or more variables from an agent. So let's say in this example, the manager wants to get the value of the system description and system uptime objects. It's going to first create a GET request message. And this message shares that common PDO format that I mentioned. If you look in the area at the top, this is the common SNMP header. Of importance here is the community. The community field represents the clear text authentication used by the SNMP protocol. In the center is the get set header, and at the bottom is the variable bindings list. In this situation, we will have the object identifiers for the system description and system uptime variables. The manager is then going to send that message to the router, and when the router receives it, the agent, the software that's running on that router, is going to create a get response message. This message looks very similar to the one that you just saw, except for in this case, those objects will now have the values associated with them because it went and looked up those values from its local database. Now the agent will send that message back to the manager, and the manager can process that information appropriately. The get next request message is used to navigate tables like routing and interface tables. In this case, it gets the value of the next variable based on lexicographical ordering of the MIB table. Set request is for setting the value of one of the variables, and in response to those 3, the agent would send a get response. The outlier here is the trap message. This is used by the agent to send an asynchronous notification back to the manager that some abnormal condition or event has occurred. For instance, if a link goes down or there's space issues, an alert might be sent back to the manager to react to that. Also note that that message, the agent has no notification that that message was ever received. Quickly moving into version 2 enhancements, there were 2 new messages added. The get bulk request message is often used to replace the get next request. This allows efficient retrieval of many variables back with a single request. Inform request might be comparable to the trap, except for in this situation, the agent receives acknowledgement that the message was received. This is also used for manager-to-manager communication. There were some attempts at improving the security model in version 2. That can be seen with the party-based system as well as the user-based system. However, due to the complexity of implementing these, everyone seemed to favor the community version 2C, which uses the same clear text community as in version 1. In version 3, we finally see some security model enhancements. They provided authentication, encryption, and integrity, as well as access control. However, it doesn't seem as widely adopted as version 2C. I'm going to turn it over to DERAL, and he's going to talk a little bit more about OIDs and MIBs.
Thank you, Matthew. So as Matthew went through the messaging process there related to SNMP protocol, he mentioned 2 terms, and that was MIB and the OID. Okay, so that's what's being used to actually query data in the system. So one of the things we want to talk about is the MIB. So what is the MIB? The MIB is the management information base. This is nothing more than a database. It exists on the device, and it holds information about that device. So that's the simple nature of it. So then when we get over to the OID, the object identifier, these are actual pointers into that database. So why am I re-emphasizing this? Because this is what's going to be the center of the rest of the presentation. So we know the protocol, but we're going to have to work with the MIB and the OIDs to actually get data out of systems. So an OID is simple. It is utilizing a dot list notation. As an example here, 1.3.6.1, it equates to this location. It's universally unique. So if you have this, you can walk down through this thing like a tree. So it's structurally like a tree. Okay, pretty straightforward, simple. I think that's simple to understand. I need to get access to this database of information, and this is how I'm going to do it. So, as an example, let's say you wanted to get the number of network interface cards or network interfaces on a device. It's fairly simple. You can walk down through this tree to the location that exists in the MIB, slowly. And we get to the point where the IF number, the actual interface number for that particular device exists. So we easily can walk to 1.3.6.1.2.1.2.1 and get to that location and get that piece of information. This in itself is probably unique on most network devices, or specifically across all network devices, amount of interfaces. But the one we're interested in, the one we find the most interesting data sometimes, is the enterprise MIB. The enterprise MIB lives at 1.3.6.1.4.1. These are specific to vendors underneath there. These are actually assigned by the Internet Assigned Numbering Authority. There's a URL for it if anyone's interested. And here's a couple examples of IANA numbers that are tied to specific companies, and this is the enterprise MIB for these companies on specific devices they may own. We have a couple examples there. We have the IBM, which is at 2. So the companies that are the oldest will usually have the lower numbers. So that's pretty straightforward. And you can go out there and query all this information from IANA and get the list of all those. So this is the beginning project, this project we have here. We call this phase 1. We have a phase 2. We may give you some highlights of where it's going at toward the end. But this is phase 1. So getting prepped for the whole SNMP thing, I found it very important. Why shouldn't I have my own enterprise number? Doesn't that make sense? So I actually went out and registered myself with my own number. So I have 43555. So the nature of the research I'm doing, if you ever encounter that number while crawling an SNMP device, my advice is you should shut your machine off at that point. I wouldn't go any further, because no good will come of that number if it actually shows up on your network. So, based on that, so we've covered the MIBs, concept of the MIBs, concept of the definition, the OIDs, how that walks down, how we can query data out of the system. Now let's get into some attacks. So I'm going to turn this over to Matthew, and he's going to go ahead and he's going to show you with some live demos, you see all the equipment setting up here, some attacks against some devices.
All right, so we started with SOHO-related devices, commonly cable and DSL modems that we have up here. The reason for that is they frequently come with SNMP enabled by default. They're easily obtainable, low cost, both brand new and on the used markets. The SNMP is frequently being used by internet service providers for management. And what we happen to find across a couple classes of devices, you'll see if you start to look into it, there's a lot of consolidation that occurs between different companies purchasing each other. So we question whether or not there's also some cross-pollination between code bases. And what we ended up finding across a number of these was that with public SNMP community, by default, these devices were giving up sensitive information, such as wireless keys, SSIDs, and interface credentials. Now, it's important that, granted, these are just SOHO devices. The idea was that this was a starting ground for this research, and that these same issues will exist on enterprise devices. So I'm actually going to perform a manual extraction demonstration, and this sort of gives you an idea of what we went through initially when we started doing this work. I'm going to be looking at the UBI DDW3611. And I'm just going to grab the OID that we happen to find of interest. And I'm going to use the SNMP bulk walk command. This is going to use the get bulk request message that I mentioned earlier when I was talking about the version 2 changes. And what I'm here is I'm providing it with the information to use version 2C of the protocol. C represents the public community. Then I'm going to put the IP address. Followed by an OID that we happen to find of interest. And what you'll see here on the screen is just a very, very small portion of the whole MIB structure. But of interest is right here happens to be a username, followed by a password for the device interface. And just to show that I'm not messing around and this is not a joke, we'll pull up a web browser. We'll go and try that. So here we see this is the UBI interface for its login. And we saw that the password was system and UBI 2015 login. So we're able to log into this device. Now that information was available via the public community by default. Now that work, takes some time because what you're dealing with is there's tables of information, a lot of counters and gauges as well. So you're spending a lot of time looking through all this information to find the little gems. There's a lot of time spent in changing parameters and then rerunning dumps and then diffing them, trying to figure out what changes when you make a change to that interface. So we spend a lot of time doing that across a number of devices. And here, just to quickly recap, here are all of the OIDs that we found on this particular device that included sensitive information. So we have the username and password for the device interface, the WP key index, WPA private pre-shared key, as well as the SSID. Now, we decided it'd be... Yeah. So we spent that time to do all that manual work, and wouldn't it be nice if we could automate that? So since we found the numbers, we took the time to develop some Metasploit modules. Everyone likes Metasploit, right? So if you happen to encounter any of these devices, you'll be able to quickly pull that information using it. So I'm going to do a quick demonstration on the Aries DG950A that we have sitting up here. And you can find all of the modules that we built under the auxiliary SNMP scanner directory. SNMP, and then you'll find the Aries module. So we're going to load that. We're going to quickly check the information for it and see that it requires our host to be set. So I'm going to set that. And confirm that that's set. And then we can just simply run that module. And it's going to dump the information for me. Right here, we'll see that we have the device interface password, followed by the SSID. We have the pre-share key, in addition to knowing what particular encryption the device is being used, again, pulled via public community by default from this device. And just to recap, here are the OIDs. The OIDs for this particular device that we found, again, just to recap those, same stuff, wireless key information, SSID, user interface information. So across all this research, here's a full list of the devices that we released advisories on. And alongside them, you'll see the current count from Shodan of what we were able to find that's still lurking out there. We're on with a total, a little over 175,000 of these devices that we found are still out there, with public community enabled by default, and as you can see, there's all sorts of interesting, sensitive information that you can pull from those.
That's exposed to the internet.
Correct. Now, while we've been doing this research, we've made some observations of trends that are happening. Well, this seems to be the result of ISPs incorrectly configuring these devices. The ISP should be rolling these out with SNMP disabled on the WAN interface. It seems some of them aren't, but they seem to be getting better over time. So as time moves on, we're seeing both incorrectly devices and older devices being phased out, while the newer deployments seem to be more secure. And I'm going to turn it over to DERAL, and he's going to take this concept, right, from the Soho grade issues into the enterprise world.
Thank you, Matthew. So enterprise device attacks. That's the stuff I'm interested in. Things that I can leverage during assessments, pen tests, to compromise companies, corporations, government agencies, literally around the world. So S&P available on all enterprise devices. That's a fact. Enterprise level devices, every one that I've encountered, S&P is enabled by default. And they're often actually found configured with public community string and enabled by default. So based on that information, we can do some attacks against certain enterprise devices. In this case here, I was doing an assessment against a state government, agency of a state government in the United States. I encountered a Brocade server iron, ADX, exposed to the internet. They had S&P enabled on the device with public as the community string enabled also. And we have a little demo about that, so I want to show you what I was able to find. So what we did was the actual device is extremely expensive. I think it's like 12 grand. So Matthew found a program. If anyone's interested, talk to us offline. We can actually simulate the S&P on a device.
Yeah, it's called S&P Sim. It's a Python project. It's quite interesting.
So that gives us the ability to simulate the S&P for this device without actually bringing a $12,000 device. People don't like to give me $12,000 devices. So we're going to go ahead and we're going to dump this, and I'm just going to dump it to a test file. So you see as this dumps through, there's a lot of data. Again, I reemphasize, this is a lot of data. So I'm going through an assessment. Let's go ahead and see how much data this is real quick.
I missed that fourth line from the top. Can you go back?
So there's actually over 12,000 lines of information in here. So I'm doing an external assessment, okay? So the thing is how in the world do I get information out of this? Do I have time to look at 12,000 lines of data? And the answer is no. But on that particular assessment, I dumped the data, and I actually searched for admin. And as we see up here, I was able to find the admin. But when we step down below that, we see other items of interest. So you see these all starting with $1. Well, what that is that's the kind of the older style Unix password hash, the MD5 crypt hash style. On that assessment, I was able to hit the device, do a search for admin, find that, and within close proximity of that, quickly find the hashes stored in the system. So this took me 10 minutes because I started thinking about speeding up this process of identifying potential attack vectors and identifying data. With this, we went ahead and cracked the password, which gave me a foothold through their device into their internal network. So I compromised them using S&P on a device with a public community string enabled and exposed to the internet. So jump back here with these slides real quick. Here is the actual OIDs for those locations where the username and password hashes are actually stored on the device. Moving from there, This was not too long ago. This was about a month or two ago. A gentleman, because I've done a lot of printer research, and if you've been involved in seeing previous presentations, contacted me and goes, hey, I actually located some information being stored in the MIB tables that were actual password hashes for Active Directory for the scan the file functionality on Kyocera devices. So I credit the two guys up there that have found this independently within the last year and publicized it. So if we go ahead and we, so I actually have a dump here of one we had during an assessment. It's been cleaned up so it doesn't contain any company data. Let's see if this gives it. So quickly it dumps this data here when we just use grep to parse that range out of there. And we quickly find in this case here, we end up getting the path for the storage, the host name of the device, the port numbers, the usernames, and all the passwords in plain text for Active Directory access or Windows access to those machines. Quite significant exploits if you're happening to gain some kind of foothold or somebody who's stupid enough to expose one of these to the internet. You can gain a lot of usable information. So moving from there, we have another example, another demo we're going to talk about here, dealing with log data. So let me go ahead and log in here. It was 11, right? Yeah, 11. So we telnet to this device. Ah, shit. I hate when I do that. How many times have you done that? So how many people here have entered a password in the logon area? How many people have done it in the last week? How many presenters have done it today in a demo? Well, we even knew what the password was, but one of the presenters actually did it today. But we already knew what the password was. So we do this. We all do this on a regular basis. Where's that data going? Well, it turns out that in certain devices, they're storing log snippets in the MIB data. An attacker could potentially use that to get this information. Matthew's going to go ahead and show you the damage that I did here.
All right, so we all saw DERAL's failed login attempt. Let's consider the disadvantage if that information was actually being logged. And in fact, the device that he logged on, the Netopia that we have sitting up here, actually has the logs stored in a portion of the log being stored in the SNMP table. So we're going to walk what we identified to be the starting point of that table. Again, configure SNMP bulk walk with version 2C, public community. And paste in the MIB that we identified. And you'll see up there on the screen, we have a portion of log, and at the very bottom, which would be the most recent login attempt, it happened to show his failed login. Now, this would normally probably have a number of successful logins. In this case, it happens to be a failed. So if you have a combination of failed and successful, that's more information for us that could be useful later. In addition, we also see the host that the person was trying to log in from. If we happen to see that the admin continually logs in from a set IP address, that could also be a target for us when we want to move into this network. So when we encounter a device on a pen test, we really need to see if it has SNMP enabled and it's accessible to us. If it is, then we should SNMP walk or bulk walk that device prior to engaging it with a brute force attack against any of the services on that machine or device, because we could overwrite potentially useful information that would save us a lot of time on our engagement. And obviously time is what we have little of. Just a quick list. We want to show that this is actually something that exists across multiple devices. There's just a quick handful up there of devices that we happen to find that had a portion of the log available via SNMP. But there are plenty more out there, I'm sure. And I'm going to turn over to DERAL. He's going to talk a little bit more about moving us forward into automated harvesting, because obviously we spend a lot of time looking through that information to try and find it. If we could speed that up somehow, it would allow us to move further quicker.
Thank you, Matthew. Again, on the log, those few examples there are actually devices that store failed logins from the user, so you can capture passwords in those. There's a lot more that I found, probably at least a dozen more that store logs, but they don't necessarily store the username during that process. So automated data harvesting. So what are we dealing with? And I mentioned this earlier a couple times. We're dealing with large amounts of data. We're also dealing with unknown meaning of that data. Because to really know the meaning of the data, you have to have the MIB supplied from the vendor. And a lot of times, those MIBs are not published. So you don't actually know what that data means in a lot of cases. And if you're doing assessments or pen tests, we're limited time to analyze that data. It becomes inherently difficult to be able to look through a lot of data. And we're gonna play up some of the stuff I did earlier where I searched for certain keywords. We're trying to build upon that. So how do we get this data? So how do we gather useful information? The first thing we need to do is do an SNMP bulk walk against a device, and which Matthew did as an example, I did as an example. We ran SNMP bulk walk. If I'm on an engagement and there's 100, 200, 300 devices in there, how do I deal with doing SNMP walk or SNMP bulk walk on 200 or 300 devices? It's very time consuming, if not impossible. And then we also have to be able to parse that data for something useful. So we created some tools. In this case here, I created a tool called SNMP BW.pl. These tools are still works in progress. We're still cleaning up the code. So if you're a Perl guru, you're probably going to look at it and go, that's not very good code. It works pretty good. In this case here, it's multi-threaded. It runs SNMP bulk walk binary. Why try to reinvent the whole walk process? It exists on your OS X. It exists on Kali, Ubuntu. Those commands already exist, so I'm going to leverage those, but I'm going to multi-thread them so I can rip through a network fairly quick. There's the GitHub for downloading that. Also, we have another tool, and this is a parsing tool. This one's probably actually really poorly written, but it'll get fixed up soon. It was put together quickly, and eventually we're going to combine these into one tool so we can speed up the whole process and not have to run two tools. And it's a Perl script, and it parses the SNMP walk data or bulk walk data that you bring down. So I think we have a couple examples here in just a second. Oh, yeah. Well, so what are we looking for in this process? And I think we showed it. If I can get usernames, if I can get passwords, hashes, those are all good. There may be other data like network structure data that you want to look for or parse out of the system. So the reason for these tools is to be able to gather massive amounts of data, and then you can determine yourself what you want to look for. That's what we want to do. We want to simplify that process. Here's a couple samples for data parsing that I got showing up here. These are ones I use for grepping. The first one is looking for a standard hash structure. And there may be ways to improve these regular expressions. The second one looks for a standard MD5 structure. The third one looks for like an email. And then what about keywords? Trap host, and we're going to talk about that in a minute. Admin, root, fail, success, logging. Sometimes that'll identify the location of logs in the system, because it's not uncommon on some devices that I pulled down to see upwards of 10 to 20,000 lines out of a single SNMP bulk walk. So to be able to get through that data, and you're going to manually look through it, it's going to take you a while just holding down the down arrow just to get through all that data to visualize it. So that's not actually reasonable. So let's go ahead and look at this from a demo standpoint and look at running some of the tools that I had put together. So the first tool, I hope you can see that up there. Good, you can see that up there. We see the simple command structure. It'll take an input. You can input a single IP address, you can input a CIDR, or you can input a file containing CIDRs or IP addresses. The third one is the actual public or whatever the community string you use. Since public is the default for most devices, and that's usually your attack entry point sometimes because you don't know what that custom SNMP community string may be. The fourth one is the actual timeout, and followed by the number of threads. So we have a network up here, and we actually have 4 devices on a network. It's common when you scan a network, you may not find hundreds of devices with SNMP enabled on a /24, but you may find 3, 4, 5. Before we had single threaded this, and it would take like an hour to run through it, or 45 minutes to run through it, but we wanted to speed it up a little bit, so we multi-threaded it. So let's go ahead and look at that. And then we go ahead and put the community string that we're going to use, followed by the timeout. If you're on a slow network, you may want to speed that up or slow it down to a higher number. And then the threads. In this case, I'm brave. I want to speed this up. So let's try 64 threads against this /24 to see what happens. So it's ripping through it fairly quick. It's already pulled down the running the SNMPs from a couple devices. And then it gets toward the end. We'll probably have about 2 seconds of timeout for each one of those. It'll rip through those. So it goes fairly quick. As you see, boom, we're done. We would /24, figure we're going to have 4, 5, 6 devices that may have SNMP enabled on it. If you do a /64 and all the devices on there are enabled, you may have a little problems with that many threads really pounding heavy I/O. But let's kind of look at the data. So we quickly see that the ones ending in .SNMP, we were able to pull from all these devices. And it checked every one of the devices if there was something up at that location. If there was, it pulled the information. So it was fairly quick. So moving from there, we want to look at some real data. So we come over here. I have, I think it's 540 SNMP dumps here from 540 different devices. So if we go ahead and cat that, let's get the word count. It's actually 2.8 million lines of information. It's pretty significant. So if you just did a dump and you need to look and find cool stuff in here, I feel sorry for you if you haven't figured out a way to parse this stuff out. So that's where we're trying to solve, or at least move in that direction here. So we have our program here, SNMP PRS. It's real simple. You just put in the name, you put that in the file where the SNMP dumps are, and you put the output file where you want to put the data. And then we also have a regular expression list that you can add stuff to. In this case, we have 4 items added to it. So you can see up there. It's going to pull email addresses and hashes and all kinds of stuff there, and the word trap host. So let's go ahead and run the program. We need to give it the name of the file we want to call it, so we'll just call it test.txt as an output. We run that. It marches through all this data. It dumps it all out to the screen. It's going to dump the IP address, the OID, and the string information that we actually parse for. So as you see, we're dumping a lot of email addresses out of it, maybe valid information during a hack or a pen test that you want to leverage. You'll see some things go by that have trap host in them. This will finish up in a second, and we'll go ahead and I'll open it up, and we'll try to look through there real quick, because I want to talk about the trap host as an example. So, boom, we just ripped through 2.8 million lines of information after that we were able to dump all this stuff. We quickly found some keywords, some regular expression stuff that we were looking for that may be of value. So let's go ahead and look at this data. So we see email addresses, but let's go ahead and jump the trap because we were searching for trap. So quickly we see that we have a number of trap items here. And this happens to be, in this case here, I think you can barely make that out. It says big horse, you know, with some lead speak type stuff there. This is kind of interesting because we actually use this on engagement. What that is a company had one Cisco router misconfigured with SNMP on their entire network. It dumped the SNMP. We were able to dump the SNMP off that device, crawl it using this process here, searching for the word trap or trap host, and we gathered this information out of the SNMP dump. What this information is a configuration on the Cisco device for it to communicate traps. Inevitably, in this case here, those traps also match their private community string. We immediately were able to dump all the running configs off all the routers and firewalls in the Cisco environment because of one device and the fact that we knew we can look in here and use this method to glean data out that we could use as an attacker. And if we had time to look through here, we'd also find, besides email addresses and stuff like that, we'd actually find hashes from some devices. But you can see how quickly, you know, we can speed up the gathering process, speed up the parsing process with a simple program, and we're going to make it faster. We're going to make these programs even better as we move forward. So Matthew's going to kick off, and we're going to start talking about some SNMP security best practices.
All right, so we spent some time talking about all of the issues that you might encounter with these embedded devices on your network, leaking out sensitive information. We don't want to leave you, on a down note. We want to make some suggestions, and we're going to start with manufacturers. We'd like to see the SNMP is disabled by default. We also like to see them move away from using version 1 and 2C's clear text community in favor of version 3's stronger security model, and that the MIB objects probably shouldn't contain sensitive information. I think we can agree that finding passwords, hashes, usernames, and even community strings within that MIB is probably not a good idea, and that the data that we find there should be related to the logical systems on that device. DERAL, what can end users do to mitigate their risks?
Besides turning their equipment off and going home? Yeah, there's some solutions that can be done. First thing we need to do is assume the manufacturer is not going to solve your security problems. It's your job to solve your own security problems. So how are we going to do that as end users? We're going to start off by disabling the devices prior to deployment. So you as an organization, if you do not utilize SNMP as a management protocol in your environment, you need a process and procedure for the deployment of all systems. That process should include turning off SNMP if you're not using it. If you are using it, then you need to consider setting strong SNMP community strings. The example I say here is 20 characters. That would be alphanumeric, upper lowercase, special characters, and not a single dictionary word. Because technically, you're never going to change this, are you? You're going to put it in place. So you don't want to make it easily guessable. You're going to totally mess up by doing that. Also, your community strings should not be the same. What I'm saying there is you have the public, you have the private, and you have the trap settings. They should all be completely different. The Cisco example, we were able to use the trap host information, the trap settings, to gain access, elevated access into their environment, and pull down all the running configs. Very serious breach, in my opinion. So those should be different, and they shouldn't be lamely different. And what I mean by that is you don't want to have them different in the fact that they have the company name by RO, ROW, or trap at the end. Because when I get one of those, I'm just going to change the characters at the end and replay it. Higher probability I can compromise you with a brute force attack in that method there. And then at the end, community strings should be different based on security levels. So what I'm saying is, if you're an SNMP shop across the entire gambit of all your environment there, you may have IP cameras. You may have Cisco routers and firewall devices or critical system devices. Those are items of different security levels. They should not have the same password, which is what a community string is. Because a IP camera may be weak, vulnerable, exploitable, because you're never going to patch the thing. We all know that, right? So if I gain access to that, do you want your most critical infrastructure compromised? So you should treat them differently. That is the ultimate way to handle the security with the SNMP environment. So as we get into concluding here, we've covered a lot of different things. I hope you found this very interesting, enlightening. We have these tools where you can gather information, possibly harvest data. We talked about attacks against SOHO devices. Actually, there's like 170,000 devices on the internet. I know 68 of those devices on one of those products is right here in Paris, exposed to the internet. So everybody's exposed in those devices. So if you own one of those ones on that list, get rid of it. But this was kind of the conclusion of phase one, coming here and doing this. So we have phase two. So think we should tell them anything about phase two, which direction it's going?
Sure, why not? We're looking at using SNMP as an attack vector.
So that's about all we can tell you right now, but probably within the next 90 to 120 days, we're going to have some advisories coming out where we're looking at leveraging SNMP in a way that we can attack the environment. And we're ready for questions, so.
Yeah, I got two, but I'll start with one. I'm speaking loud because I don't have a mic. Oh, now I have a mic. Can you address ports 10161 as well, and how secure SNMP is either affected or mitigates this?
Say that again? You lost me.
Secure SNMP.
Secure, oh, you're talking version 3.
Yeah. Can you address that at all?
We haven't really dug into the protocol at any level, and one of the reasons why I haven't paid much attention to it, how many people here are using SNMP v3 in their entire environment? Got one? We got one. And that's usually the case. Yes, from what I understand, it should be a fairly good protocol, but it might not necessarily be easy to implement completely.
What you're seeing is there's a lot of devices will come, it's like supports 2C and 3, and even though it supports 3, deployment seems to still be in favor of 2C.
Yeah, that seems to be the case.
I think there's probably some interesting things in 3 because it hasn't had enough attention given to it yet.
Haven't had a chance to encounter it. I'd love to encounter it because it would intrigue me to probably dig a little further, most definitely. Any other questions?
I got one more. You mentioned VLANs up there on one of the earlier slides. There's been some discussion recently about potential vulnerability in aircraft between avionics and entertainment systems running on VLANs. Do you know of any research that would determine if any of these systems are properly configured or not?
I have no answer to that, Wynn.
That's a hot question.
I agree, but I haven't looked at SNMP deployment on a plane yet.
We still have to fly home.
I'm still going to tweet that you did, so.
That's fine. What was the other question?
Hi. First of all, thank you very much. That was very eye-opening. Can we expect, on the more reconnaissance side of things, a plugin for a Maltago or a Metasploit with the tools you're working on?
You're
Do you want me to repeat?
a Metasploit plugin for the tools, the stuff we're getting ready to do?
Or Maltago?
Yeah, I'm not sure about Montego. But yeah, as we find exploits, I work for Metasploit. For me, if I actually find an exploit,
of course,
and I don't run a Metasploit module, people start asking me questions. Okay, so yeah, the ultimate goal is any real exploits. If we can Metasploit those or make them a Metasploit module, we will. If not, obviously, when we get around to releasing the pieces of information, we'll probably we'll release everything. That's how I work. So everything I do is open source. No matter what we find, pull off, code we write, as well or bad as it may be written, it's going to be released to everybody. So nothing will be hidden. And if we can write a Metasploit module for it, and it's Metasploitable, if you know what I mean, it can be,
Of course.
then that's what we'll do. We'll make it available. If anyone else wants to take our information and write exploits or mmap scans or anything that's usable, I encourage you to do it. So please do.
Thank you very much.
Thank you.
Just a question?
Thanks. Hi. Let's say I've got a camera and I'd like to SNMP walk it. How do I know which OID I'm going to start to, the base OID I'm going to start to have a look at?
One.
Yeah,
So-
well, will I get everything with one or?
I just typically when SNMP walk or SNMP bulk walk, in the command at the end where it asks for the OID, just put 1 in there, the number 1.
Yeah.
Okay.
It'll start at 1 and it'll walk from there. Or if you're only looking for the enterprise stuff, then
You can
it's-
move it down to an
you
enterprise.
can move it
mode
down
or-
to any one of those levels there. So 1.3.4. 1.3.6.1.4.1 is where the enterprise MIPs start. So yeah, best thing to do, start at 1. All the tools that I've written here that bulk walk, every one of them start at 1 and tries to dump everything. Now I have been told that there are OIDs that are completely hidden. And I've heard several references to that. I have not got into that. Obviously, that would involve some kind of fuzzing of the devices. But I'm not sure how many vendors do that type of stuff.
Okay, thank you very much. I think there's nothing hidden on the camera. It's only to plain text.
Thank you. Any other questions?
And continuing the line of Excel, can't we reverse engineer a firmware in order to discover such bizarre OIDs?
We haven't done that, but I don't see why you wouldn't find those OIDs lurking within a firmware. Right? If it knows where it's sitting to respond to something, I would imagine that data would be out there.
Yes.
Can't say, for certain because I haven't actually taken that approach, but I don't see why it wouldn't work.
Thank you.
Absolutely.
Any other questions? Well, thank you very much.